All right. Thanks a lot, Brandon. Thanks everyone for sticking with us. I hope you're enjoying the workshop so far. If you are just joining us, we're going to give you a reminder. Hit the gear down in the corner of your video stream to make sure that you've set it to HD. YouTube defaults to low D, and so you won't be able to see lots of the screens and see much resolution if you don't change that to HD. This next talk is about parameter linking and advanced parameter linking, as well as user params. And we'll go through and talk about why you do this and then how to do it. So linking, why would you want to link? And we'll talk about what linking is as well. But linking allows you to establish some relationship between disparate parameters. And doing this allows you to change the parameters of a model, essentially. You can build your designer intent into it so that you build what you want your model to be like into it. And through that, you reduce the design space dimensionality. So instead of, when you're making a change, having to update 5 variables, you may only have to update 1. And through this, you can even go so far as to introduce new parameters and new physics and some physics into your model. And used appropriately, all of these things can be really powerful to allow you to build very expressive models with as few parameters as possible. That's important because in general, you always want to use the smallest number of parameters when you're doing some sort of a design or an optimization study, just because it makes everything a lot more intuitive and faster. So first off, there's user params. There are, I think, 15 predefined user params. Frankly, these aren't that useful because they don't have great names, user 0 to user 15. Instead, what I'd really recommend you do is come over to the Create tab if you want to make user params, and this allows you to come in and name the parameters yourself. You can give it a name. They'll always be in these certain groups, but then you can give it a minimum and a maximum of value. And so you can create parameters like disk loading, gross weight, number of disks, disk area, disk spacing, something like that for a VTOL model. And whatever kinds of parameters you want. And then again, through linking, you'll be able to use these to drive your model and determine other things. So in general, go ahead and create a named user param when you need them. The last tab on user params is the adjust. And so here, any of your created user params that you made, you get the ability to come in here, and this is where they get a slider. So you can come in, you can adjust their values by sliding them around right here. Okay. Linking, and we're starting with simple linking, allows you to create a linear relationship between any two single params. And this relationship is right up here in the title bar. So parameter B is equal to parameter A times the scale plus an offset. So you've got a linear relationship between two single params. And then in the GUI, you'll notice we have parameter A here on the left and parameter B on the right. So these are pull-down menus to choose what the param is. You can set what that scale and offset values are, and if you want to use the scale and the offset, you can even limit the extent that you'll allow it to go. And you set all this up to set up a link, and then you say add link. And that link gets then displayed down here. And you'll see that in this case, they've linked where a pod's length is the driving parameter that then determines its fineness ratio. So B is a function of A in this case. And so you've linked the length to the fineness ratio of a pod. It's a little silly, but it illustrates the point. So this is simple linking that's been around a long time. A little bit more recently added is what we call advanced linking. And the way that that works is you get to pick any VSP params you want as input params, and those will have their own identifier that VSP uses. So first we map them to an input variable. You give them labels. Instead of wing aspect ratio, which is a very long name, you map it and you might just call it AR to give it a simple name that you're going to use in code. So first there's a mapping between the params to the variable names you want. Then there's the code. What do you actually want to be done, to be calculated. And then there's the output variables, where you have output variables as again, named quantities in code that then get mapped to the VSP parms. And so this is sort of the process for advanced linking. And to do advanced linking, you're specifying this mapping on the input and the output side, as well as what code happens. The advanced linking GUI, first you can have different advanced links. So you name them. So there's the add, delete all, and name box up here at the top to create them. Then there's an area for picking the parms. So you can use the pull down menus to choose the parm and give it a name. So when you want to create a mapping, that mapping for an input parm, you'd put in a name here in the var name. So for example, for disk loading, you'd call it DL. So you type in DL here, and then you'd browse to the disk loading, which happens to be a user parm, and you'd say add input var. As an alternative, you can type in DL here, and then drag and drop that parameter to this input parm box. And I'll demonstrate that. Hopefully we'll have time for a live demo. But the drag and drop is a really great way. But you give it a name, and if you drag and drop it into the output parm, then it creates an output mapping. And if you drag and drop it to the input, then it creates an input mapping. But this shows your mappings. And again, you can delete and delete all on your input and your output mappings. So that's what this part of the GUI does. And then down here is where you put in the code. So this is, you just type in your code using these variables that you've specified, and you do your calculations. Here we do a calculation of the disk area, we calculate the diameter of the disk, we have the number of them that are going to be output. So here we do a spacing calculation to determine the Y values of that, where we have our end disk there, and then we determine the angles. So this was something to go out and calculate some disk spacing in a model. This code is in AngelScript syntax. AngelScript is the built-in scripting language for VSP. And so if you want to access our API natively, you'll do so with the built-in scripting using AngelScript. Or if you want to write a user-defined component, you'll write that component in AngelScript. In both cases, AngelScript is really just a very simple scripting language that is intended to be embedded in C++, and it's intended to be really easily used with C++. So that's why we chose it. In the particulars, though, what you're doing with advanced links is it basically looks like C. And to be even more simple, it basically looks like math with semicolons at the end of each line. And for most things people will do with advanced linking, you don't need to be a C programmer, you don't need to be a C++ programmer, you don't need to be an AngelScript programmer, you just need to be able to do math with semicolons at the end of the lines. In particular, what is supported is, in terms of math, is you've got all your trig functions, your log, your power, your square root, things like that. You do have exponentiation with a double star, modulus with a percent sign, add, subtract, multiply, divide, and basically anything you want to do math with semicolons. Don't do something stupid. This is AngelScript code. It is actually much more general. So you could write a while loop and put your model into an infinite loop in an advanced link. And you can imagine what's going to happen if you put an infinite loop into your own model. So in general, you don't need to do looping, right? Don't solve the Navier-Stokes equations in an advanced link. Don't do anything crazy. Keep it for simple things and you'll be fine. And with that, I'll go and do a quick demo of some of these things. If there are any questions, feel free to ask them on the fly as we're going along here. And I will try and address them as we go. So to start, I'll replicate that first example. Here's a pod, and just a default pod, and we'll start under model. First, we had the design variables, not design variables, we're in user parms, the user parms menu. And as you'll see, we have the 15 built-in user parms, and then the ability to create them. And we can come in here and we can create foo, and we create that. Now foo is a parm, and we can create bar, and create that as a parm. And we can create all these parms that we want. And then we come to the adjust, and we can adjust their values over here. And right now they don't do anything, but we'll maybe come back to those parameters in a little bit. Next, under model, we talked about simple linking. So that's just the link tab. And that pulls up. And as we said, this allows us to create a linear relationship where B is equal to A times a scale plus an offset. So we've moved this around from when the screenshot was done in the presentation, so that now A is on the left and it shows up on the left and B is on the right. So that's nice. But as an example, we can come here and say we want to do what we did there. So we'll start by choosing the container that's going to be the pod. We're going to choose a design, and we want to do the length. And so the length will be the driver, and we want to link that to the design to the fineness ratio. So we've chosen those two parms. And what VSP is going to do as you're setting this up is it's going to calculate right now what it thinks you want to do. So right now it's just going to do that with no scale, but with an offset of 5, because that would create that same relationship. It calculates here an idea for the scale, so that if you instead wanted to scale them and not offset them, if you just flip those, now it would, again, create the same relationship. Minimum surprise principle here. It's going to, when you create this link, it's not going to change the model. But what we're doing here is now we're going to say that B, which is our fineness ratio, is 1.5 times the length. And so if we say add link, we've created that link. And you'll notice that the fineness ratio is now red and the length is green. And green means that it participates as an input to a link, and red means it's an output of a link. It's determined by a link. And so if we change the length, because that's the green one, as we change the length, notice the fineness ratio is updating. And in fact, because of the relationship of this, we're actually maintaining a constant diameter. So we've linked these parameters, and we have that linear relationship. Now, other neat things you can do is if you click on the length button, it pulls up some information about that parm. It gives you its name, its group, its description, its min, its max, its current value. But also, if you click links, it shows what links it participates in. So here, it's a driving link on some, it's a driven link by others, for both advanced and regular links. So there's information about that if you just click on the head of it. The other thing that you can do is if we delete this link and we want to recreate it real fast, instead of choosing through these pull downs, because that's a little bit laborious, what we can do is we can actually drag and drop. And this time, let's do the opposite. Let's have B drive A. So here we can drag and drop from this button for the fineness ratio, and we drag and drop onto that, and boom, it sets us right up. And likewise, we can drag and drop the length here, and it sets that length. And so a lot less effort. We just we drag and drop those in. We've got a scale. In this case, it's 1 over what it was before to get the, again, minimum surprise, the same effect. We say add link. And now everything's reversed. Green and red are reversed. But now the fineness ratio is driving and the length is driven. So that's an example there. Let's go ahead and delete this link just to simplify. That's pretty much everything on regular links. We can also go into advanced linking. And here, what we're going to do is start by creating our first link. So there we go. There's our first link. And we're going to do something similar where first we need to create the var name. So here we're going to want the length to be len. And as I said, we can come through here and we can choose pod, design, length, and we can say add an input variable. And then we're going to have FR for fineness ratio. But instead of going through the pull downs, I can just grab fineness ratio and drop it on the output box, and it'll create it with that name. So now we have two mappings. Remember, we said we had to have a mapping of the parameter to a code name. So we have inputs of len and outputs of FR. And so here we can just say FR, since it's an output, is equal to, well, to be simple, we can say, 0.5 times len. Math with a semicolon, put a semicolon at the end. Then you hit the compile button. It's red right now, just showing that it has not been compiled. We hit the compile button. It not only compiles it, if it's successful, it'll go gray, but it then applies it for the first time. And once again, our red and green relationships up here show us that we've linked something. And so now if we change length, we see that our fineness ratio updates. Of course, we can do more complicated things. For example, what if we wanted to do that the fineness ratio is 1/2 times the sine of the length? This will be probably terrible, but it should be hilarious at the same time. Since this is C, that means that it's going to interpret my length as a length in radians. So let's compile it, and let's see what this does for our fineness ratio as we change our length in radians. Well, that's kind of boring because I can't really tell that things are highly nonlinear. But you get the idea here. We could do something like maybe the log to do something more complicated. So here we'll change, and we should see that, oh, see, it goes really fast there at the end, and then more slowly as we get bigger because there's a log relationship. So you can see that nonlinear a little bit there. And of course, you can do multiple lines, and you can have multiple outputs. So advanced links allow you to have multiple inputs and multiple outputs. They also allow multiple lines of code. And I'd like you to think about these not only in terms of geometric relationships, but also think about them in terms of the physics you can implement. The example shown earlier showed making disk loading an input parameter as a user-defined parameter, and then having gross weight. And so now you have disk loading as an input, and the gross weight of the vehicle as an input, and it'll automatically calculate then the diameter of your disks so that you always have models that match the intended disk loading. I'd say you can go much further and do more complicated things. For example, you can build a model where the tail area is driven by a tail volume coefficient calculation. And the tail position is at the end of the fuselage, and you can enforce that through attachment. And so then when you go and you change the length of the fuselage and you have a fixed tail volume coefficient, it will automatically shrink or grow the tail to match the desired tail volume coefficient. Another example might be that if you are designing UAVs that communicate through a satellite dish, then you might have a set of algebraic equations that relate the diameter of your satellite dish to the bandwidth and the gains and other parameters about your antenna. And so now you can have an antenna that automatically gets sized based on the bandwidth requirement for that vehicle. And you could even go so far as to put in the relationships about your sensor, how many megapixels and how many frames per second, and or even all the way to pixels on target and a nears calculation as to can you identify the target. And so then you can have something like, if you need to be able to identify a video target from a 12-mile slant range in infrared, and you're going on KU band satellite, you could have links set up to size both the optics of your sensor as well as the size of the dish, all based on what's your slant range and what's your requirement for your sensor. So you can move parameters from being purely geometric to include the physics or the payload or whatever's driving your design. And that can be a really cool, powerful thing for your VSP model. And I think that's really all I had planned as a demo. I'm happy to take any questions about parameter linking as we go.
Yeah, Rob, there was a question that was asking if we can put intermediate variables within the advanced parameter link. So I think that's mostly, say you compute something and you say that A is some calculation and then you use that variable later. I said that we absolutely could, but I don't know if we need to demo that. I think that answers the question, but it's totally up to you.
You can, and the thing is, you just have to treat it kind of like C. So if it's a double or an int, whatever it is, you say double, as you said, A, is equal to, say, len over 2. And then here, fineness ratio is equal to a times length. So now we're going to get a squared relationship here, but we can compile that. And now as we change length, we're getting a, there's the fineness ratio is turns out the square of the length divided by 2. So that's a case where you can introduce intermediate variables. Absolutely.
Yeah, we just had another one pop up here that asks, is there any reason to implement a number of simple links versus equivalent of advanced links? Do simple linear links run faster than the advanced links?
So there's some gotchas. There's some difficult things about linking. First, advanced links, you might invest a bunch of time in setting one of these up. And so you'll notice there's file write and file read as options over here. And these only write and read exactly what your code is. So if you've written some incredibly beautiful code that does exactly what you want, you might want to file write and save that off for posterity in case you want to reuse it in another model or you need to read it back in. So that's the first thing, is you can save this for later. The next thing that happens, and this is a bit unfortunate, and we probably ought to make this more friendly about VSP, but this link only exists and only works as long as these parameters exist. So let's say that we have a model that's a little more complicated. It's got a wing and a pod. And here we've got our first link, and we can make our second link. And we're gonna, sorry, I just renamed that one. There's first link, let's add one. This is our second link. And on the second link, what I'm gonna do is I'm gonna have span as of this section as an input, and then we're gonna have sweep as an output, which is kind of a crazy thing to do. And we're just gonna say sweep equals span. And so now we have this model where if I change the span, it changes the sweep. Okay, so that's kind of weird, but that's what I wanted to do. So we have two links. One is pod only, one is pod and wing. And I'm going to go ahead and add another one, and I'll say this is third link. And here I'm going to say that the input is the area, and I'm going to take the wing area here. Let's use the record. No, we can change the area. Why not? We'll change this to an area. So now it's a driving parameter. So now we have area as an input, and I'm going to make the X location of the pod is the output. And so we'll just say that X equals area and compile that. So now the X location is now over there at 50. And as we come to the wing, again, as the area changes, the pod moves, right? It translates. So the point here is that we now have three links. One is using only parameters of the pod, one is using only parameters of the wing, and the other has both wing and pod. When these update, it's going to go through and update these in order. And so if there are any loops, if you have loops in your advanced links, it will try and resolve those. If they go in order, it will try and resolve them. Generally, for the most part, you're going to want to avoid situations like that because it just creates counterintuitive behavior. The gotcha I wanted to address is, what do you think happens if I delete the pod and the pod no longer exists? And I'll demonstrate it in a minute, but what's going to happen is any of these advanced links that involve the pod, unfortunately, this is not very user-friendly, are going to get deleted. They're going to get blown away. And so remember, we had a pod only, a wing only, and a wing and a pod. So if we come up here and we just delete the pod, it's going to blow away. Those two, the pod only and the wing and the pod links, got blown away. And the only link that survived was the one that's the wing only. So because of this, um, you're going to want to most likely not put links into your model until you've really established the baseline model. You've got the architecture added, you've added all the components you're going to add, you've set the exec types, you've chosen the airfoil types, you've chosen rounded rectangle or super ellipse or whatever you're going to use for your cross sections. You've chosen those, you've set up your model, you know how many cross sections you're going to have. You've got those things pretty well established. And once you have those pretty well established, then is when you're going to want to go in and start adding your linking, because then parameters aren't coming and going. They aren't, and you're much less likely to lose work through the advanced links. So I don't know if that answers the question, but it's a bunch more information that's hopefully useful.
All right, thanks a lot, Rob. We've got just a few minutes here before our 3 o'clock talk, so we're going to take a quick break and get up, walk around a little bit, and then we'll come back at 3 o'clock for a presentation on CAD and CFD interaction and some advanced modeling techniques. So hope everybody joins us for that here in just a minute.